Now, in the 2020 hindsight of the SARS-CoV-2 pandemic, the original SARS seems almost insignificant, except to the families of those who died. SARS was slow to infect and therefore to spread, and too lethal, doomed to die out in humans because it killed too many of its hosts. But it scared the crap out of Canadian public health officials when it arrived in Toronto in the winter of 2002-03. Anyone who lived in the city then, especially if they worked in healthcare, kept watch for its return, for the sequel. Toronto's SARS Case A became sick after his mother, who'd recently come home from Kowloon, China, became ill and died on March 3, 2003. He had taken care of her. On March 7th, he felt so sick himself he went to the emergency room of a Toronto hospital. At that point, the SARS virus had been circulating in China since November 2002. But the government of China had done an excellent job of suppressing the facts about it, insisting that it was just a chlamydia outbreak, treatable with antibiotics, no big deal. Apparently, no one in that emergency room in Toronto believed SARS might reach so far. The patient was not isolated. Those who examined him did not drape themselves in personal protective equipment, PPE, such as N95 masks. And the virus spread from him to them, from hospital worker to hospital worker, from hospital worker to patient, and from hospital to hospital. The WHO issued a travel advisory telling travelers to stay away from Toronto. Months later, it was officially determined that the virus that caused SARS was a previously unknown coronavirus. These nanometer-sized bundles of fun are basically just the genetic instructions for their own replication. An outer envelope protects a long strand of about 30,000 nucleotides of messenger RNA, mRNA, that encodes 6 genes and several open reading frames, systems that organize the translation of sequence information into proteins via nucleotide triplets that signal when to stop transcribing. Coronaviruses are decorated, as virologists put it, with protein spikes reminiscent of a crown, thus the name. These spikes hook onto molecular receptors on their victims' cells, for which they have a chemical affinity, creating entry bridges through which their RNA flows. Once inside the cell, the viral RNA is copied, and the host's cellular organelles manufacture the amino acids the RNA sequence specifies into proteins. These proteins self-assemble into new viruses, newly made RNA sequences tucked inside newly made envelopes surmounted by protein spikes. The new viruses, called virions, make an explosive exit and then do the same thing in the cells next door. They're like aliens with Terminator attributes.